Okay, so class size is a bit smaller than expected. I guess professors have already shown you this one, right? So for transportation, there will be about 8 to 12 questions. And then I will also cover a survey today. Survey, I think for most of the other parts of SE, you have already learned them in class. The survey is something new. The good news is though, a lot of the survey questions, you can use just the equations listed in the reference book to do some easy calculation. Or some others are just based on geometry or trigonometry. It's not really an engineering problem, it's more like math problem. And most of the transportation problems here, you see, we have already covered them. So just maybe you can go through some of the practice problems to refresh your memory. Let's go to, I made some prints. I want to use this one. So you can probably also tell the importance of different sections based on number of problems we have. My suggestion is when I go through these practice problems, you may want to just use this handout, the reference book part. So when you see the problem, you know where to check the equations, just to get familiar with the reference book. That's my own experience. Starting from chapter 48, planning and capacity, the first one, an interstate weigh station can weigh an average of, so trucks arrival, and then arrival rate is given, departure rate is given, performance is described as M1 model. What is the most nearly the steady state value of this truck's time spent waiting and rate? So this one is queuing system. It's M1 system. The bad news though is the queuing system is not really covered in the civil engineering part in the reference book. You need to go to the section for the industrial engineering part for the MM1 equation. So I have the electronic version here. If you have a computer, you can also use the electronic version. A industrial engineering part for the queuing system is listed here. It's a bit more complicated, but for civil engineering tests, what you need to focus on is the most useful part is this part, MM1. So this is where you have postal input, exponential service, and then one server. So this set of equation. And then another set that might be useful is this one. This is MMN. So where you have multiple servers here. Okay. So for this one, MM1, and then one number is 20, one number is 12, and it's asking for the time spent waiting. So check the definition here. Time spent for waiting is here, W, expected waiting time in the system. So you just need to use the equation here. W is 1 over mu minus lambda, so 1 over 20 minus 12. That will give you the answer, 0.125. So this is the one. The second question, traffic flow relationship. This is the QKV traffic capacity problem. And then it also gives you that V is 60 minus 0.2K. So in class, we have already covered the linear relationship between when the V and K, the speed and density, follow the linear relationship. The good news is in FE tests, all the QKD type of problem are based on this assumption. So there are some special numbers you can use. For example, this one. When it gives you the relationship between V and K is like this one, that means the free flow speed is 60. Okay. And then you can also easily calculate the jam density. So when V is 0, you set the equation to 0 and calculate the K. K will be 300. Okay. So jam density 300. Capacity. Check the reference book. So reference book for the QKD, you can find it in page 177, threshold model. The the most convenient one is just VM, maximum volume is just a quarter of jam density times free flow speed. So instead of go through the entire complex process as the solution suggested, all you need to do is 60 multiplied by 300 and then divide by 4. Okay. So jam density 300 times free flow speed 60 divided by 4. You're going to get 4,500. So this is the one. Again, all the equations for this part is on page 177, traffic flow relationship. And then part 3. Question 3. Highway, again, way station. So this is another NM1 process. And then this one asks for the value of number of trucks in the station. So this is very similar to the first question. So again, go here. So the only thing that we need to do here is we need to check the new definition. This one asks for expected number of units in the system. Okay, so it's L. For this one, then we need to use this equation. So lambda over mu minus lambda. So we check the numbers. Lambda is 10, and then 16 minus over 16 minus 10 is 1.66. Okay. So 10 over 16 minus 10, you will get the L. The fourth one, okay. So this one, vehicle parked by either two attendants. So the bad news here is this one seems to be a MM2 process. It's no longer MM1. And then it asks for what is the most, nearly the probability that is at least one attendant will be idle. So at least one attendant to be idle. First we can, this is MM2 process. And then at least one person is idle. So probability is either both are idle or one is idle. So P0 plus P1. And then we need to check here. Check the equations here. Okay. Again, for your test, you won't be given a large number of servers. The good news is it's also listed, it has already listed the probability calculation for 1, 2, 3 servers. Yeah. So you can check the table here. Check this table and then P0 for 2 servers is this one, 1 minus rho over 1 plus rho. And then P1, then you need to go back to here. Okay, this one. So in this case, rho is lambda over S, or number of servers, times mu. Lambda is a, let's see, what's the number? Lambda is the arrival rate, so 45 per hour. Another key thing is you also want to make sure the unit is consistent. So 45 divided by 60, convert that to arrival rate per minute, 0.75. And then the rho, the service ratio, is this 0.75 divided by 2 times 1, because the 1 comes from saying the attendant has an average rate of 1 vehicle per minute. So one thing you want to make sure is the rho. When you calculate for more than one server, rho, it needs to be lambda divided by the number of servers times that individual departure rate. Okay. So 0.75 divided by 2 times 1 is 0.375. This is the rho value. And then you go back here, plug in the 0.375 to get P0, and then use this. P1 is P0 times lambda over mu to the power of 1 divided by 1 factorial. So you calculate P1, in this case is 0.3409, and then you add up these two P. You get 0.79 something. So that is, the answer is D. I can assure you that in the actual test, I don't think there will be a question like this. This is a bit too complicated for the time you have. And then the next one, relationship between density and the vehicle speed. So this one is very similar to question 2. You can read directly from here. The free flow speed is 53, jam density is 66.25. So the maximum traffic volume is this times this divided by 4. So this one, therefore, is a the calculation is 878. So the answer is B. Answer is B. This is another MM1. For this type of tuning problem, you just need to identify the departure rate 24, arrival rate 15, and pay attention to the question. This one is value probably that there will be 5 trucks being weighed or waiting to be weighed at this moment. So this one is asking for P5. Go back again. So to get P5, you need P0. You need to identify lambda and mu, which we already know. So the question comes to P0 again. But again, the good news is this time it's n and 1. Okay. So P0 is just 1 minus rho. Rho comes from lambda over mu. So in this case, 15 over 24 is a 0.625. So use this one, get P0, plug P0 back to here, and then calculate the P5. So in this question, P5 is 0.036, and then so the solution is B. The next one. Next one, 15-minute interval traffic counts for a traffic flow here. So it asks for peak hour factor. Peak hour factor definition is given on the reference book, page 175. So again, tuning models are in the section of industrial engineering. All the others you should be able to find them from page 175 and page 181. Okay, so here, PHF is hourly volume divided by 4 times the peak 15-minute volume. So for this question then, go back here. The question is, what's the peak hourly volume? Because the 15 minutes volume are already given. So for this one, what you can do is the peak 15 minutes is easy to identify. It's just this 825. So the question is, what is the peak hourly volume? What you can do is you take the cumulative count. So add up these 4, okay, and then move on. Add up these 4. Add up these 4. And then eventually you're going to find out the largest hourly volume happens between 5 to 6. So when you add up 6, 75, 800, 825, and 750. And then the total hourly volume is 3,050. So you use 3,050 divided by 4 times 825. So the answer is 0.924. So the answer is B. Okay. Another thing you can remember is rough estimate. First, based on definition of peak hour factor,
there's no way that this factor is above 1. It's always between 0 and 1. So you can easily exclude C and D. And then you can see here is peak hour volume, and then you can, this one is a bit hard to tell immediately, but this one, from here to here, you can have a rough estimate of the variation over this 1 hour. This volume from 675 to a range of 825 is very close. So when you see numbers this close, it's usually around 0.9. And only when you get you see some very low values in the neighboring intervals, you're going to get a peak hour factor as low as 0.8. Okay. Next one, the traffic flow has peak hour factor 0.63, and the 15-minute peak hour flow rate is 200. So what is peak hour volume? Oh, okay. So now this means something divided by 4 times 200, something divided by 800 is 0.63. So do the calculation. This one is easy. This is 500, around 500. This one. Another one for hourly flow rate. I think this is very straightforward. I'll skip this one. Okay. Another type of question that will definitely be covered is the capacity. I know in the transportation class we learned how to calculate capacity and everything for multi-lane highway and basic freeway segment. Again, the good news is for FE, they only test the basic freeway segment. And then all the equations for basic freeway segment, okay, is on page 176 and page 177. So it's just a matter of finding all the adjustment factors. 10 feet lane, you need to find the lane width adjustment. In this case is 6.6, right? 6.6. And then 2 feet right side lateral clearance. Then you want to find right side lateral clearance. And then this is a 2 lane, so this is 2.4, and then 4 ramps per mile. And this one is you need to use this TRD, okay, total ramp density. And then the hourly volume of the freeway is 1,800. So what is the free flow speed? So free flow speed is you want to use the equation here, and then so this is 75.4 minus 66.6 minus 2.4 minus 3.22 times 4 to the power of 0.84. So the answer is around 56. So answer is A. So it's just a matter of finding the adjustment factor from these tables. Same thing here. And then I'll skip this one. So this one, 12. 12 is also about the same. The only thing different is instead of asking for the free flow speed, instead of asking for free flow speed, you see question 12 asks for the mean speed of traffic. So we first do the calculation for free flow speed for this question as the previous ones. You're going to get the free flow speed is 58.3. Okay. And then in this case, after you get the free flow speed, let me see if I have it. You are going to see from this table, the free flow speed is around 58.3, so something here. But the volume is 2,000, so it's already after the breakpoint. Okay. After the breakpoint, you need to use one of the equations, or you can do a rough estimate here. It's definitely bounded between 55 and 60. So 57, that is. Whenever you can do estimation, just go ahead with the estimation. You don't need to do the calculation. This one. So this one is the heavy vehicle adjustment factor, because this one tells you the lane width, and then it'll also tell you this is rolling terrain, and then the peak hour factor given, hour flow rate given, 15% trucks versus 4% recreational vehicle, and then population factor is 1. So for this one, you need to use on reference book page 177. So this one. So V is given as 1600. Peak hour factor is given as peak hour factor is given as 0.8, right? 0.8. And then this is the standard lane, so no lane adjustment. Actually, we don't need to use it anyway. So number of lanes is 2 lanes, so N is 2. This comes down to FHV and FP. This, if population adjustment factor is 1 already given, so it's FHV. FHV, you want to use this one, and then this one, this refers to the percentage of truck, this is percentage of recreational vehicle, and these two are the passenger car equivalents of these two types. So check this table and get these numbers. You get FHV, in this case is 0.79. Do the calculation. The answer is C. So next one, same thing. Demand flow rate. Just use this one and this one. Do the calculation. Question 15. Question 15 is easier. It only asks for heavy vehicle factor. So same thing, just check this table and then do the calculation. Find percentage, find equivalency. That's it. And question 16. Another demand flow rate. So 16. But the question is a little different. This one is asked, it says 6-lane freeway has a density this much. Mean speed is this much. So what is the flow rate? So instead of using all the adjustment factors, this time it's given, the density is given. So here. Okay. And then the speed is also given here. So you want to use this equation to get VP. So VP in this case is E times S. So 15.3 times the speed 60, and we're going to get the VP is around 920. So it's not. This one. What is the level of service of the freeway segment? Remember, the freeway level of service is based on calculation of density. So the process is you first need to calculate VP and then calculate S and then do the calculation. So VP, I just said you use this equation. So in this case, it will be this 3,400 divided by peak hour factor 0.75 divided by number of lanes. In this case, is 3 divided by heavy vehicle adjustment factor 0.82 divided by the population adjustment factor 1. So you first get VP is about 1,800, and then you do the calculation for speed. Speed is also given, is 55 in this case. So to do the calculation, you find out the density is 33.5. Let me see, I think we have that. So when you check this table on page 176, it will give you 33.5 is here in this level. So level of service P. So everything about free flow, level of service, freeway, level of service, capacity, calculation, Just all the equations are here. Okay. Question 18. Same thing. You just need to find dT here, already given, and then speed, also given, 70, and then directly find out the level of service. So 845 divided by 70, you get 12.07, and then check the table, you get D. This is the type of question you're more likely to have in the FE test. Not this question 17, it's way too much. Then 19. So, similar. Flow rate. This one, 6-lane highway has a free flow speed 65, observed density here, and then jam density. What is the flow rate? Okay, you use the green shield function, green shield model. The speed V equals the free flow speed minus the free flow speed over jam density times the density. And then flow rate is just the density times the speed. So do the calculation for this one around 8. Okay. 20. Maximum flow rate is given. Again, whenever you see maximum flow rate is jam density times free flow speed divided by 4. And then free flow speed is given. And then expected density during evening rush hour is 250. So in this case, what you can do is, based on these two numbers, you can first calculate the jam density, right? So this multiplied by 4 divided by 60, you're going to have 600. That's your jam density. And then the next piece of information is 250. So this is the given density currently. You have jam density, you have current density, and then you have free flow speed. Asking for the current speed, you use the green shield model. So speed S equals free flow speed SF minus, again, SF over dj times d. So 60 minus 250 times 60 divided by the previously calculated 600, you get 35 here. This one, road facility designed with optimum density. Again, for green shield model, optimum density is half of jam density. So you see this, you know the jam density is 300. Free flow speed is 50. Expected density during morning rush hour is this much. What is the flow rate of the proposed flow rate? So to get jam density is 300, and then same thing, you use green shield model. Green shield model. This case is this one to get the flow rate. Here. Okay, so you have SF, you have D, you have DJ, you have D. Do the calculation of D. Question 22. Another one. Solve the jam density beneath. Maximum flow rate, jam density, and then zero density and zero flow rate conditions. Most nearly, what is the theoretical speed of the first driver? This is given the jam density, given the capacity asked for free flow speed. So this times 4 divided by this. That's 65. Okay. Freeway facility optimum density. Again, optimum density is half of jam density, so jam density is 250. There, see. Okay. So this is for the first part. Mostly covered by page 175 to 177 on the reference book.
And then the next part, I want to I still want to go through the reference book because I think the practice problems, that set of practice problems are not that good. I compared this set with the other set that I printed, the FE Civil Practice Exam. This one is more comprehensive, although it has fewer number of questions. This one at least have also some planning questions. So I personally think a good way to review is to go through these equations to understand, just to refresh your memory, know how to use them. Like this one, this is for gravity model for distribution, where you have production, attraction, how you distribute the trips. Okay, this one. And then something else not covered in this chapter, but probably will be covered in the FE test, is also loaded model. Loaded model is used for mole split, the third stage of four-step method. How you calculate it? It will probably give you the time, the cost for each mode, and then you use this to calculate the utility for each mode, and then you plug the numbers into this equation, this loaded model, to get the percentage of each mode being chosen, the probability of each mode being chosen. So these two equations. Okay, with that, I think I'm more comfortable with the traffic capacity thing. Now, then I want to talk about survey. Survey, there will be about 4 to 6 questions. As you can see here, if you want, the FE review book has detailed explanation. I just want to show you the type of questions it will ask, and then where you can find the equations. So survey-related questions will be covered. All you need to use will be on page 182 on your reference book. Just these 3 equations. Okay. So for example, this one. This one gives you the profile view of some segment, row segment. So this is this like the horizontal distance. This is the elevation, and then it asks for the total area between the irregular boundary and then the traverse line. So you can use just geometry, calculate, add up all the areas of the trapezoid. Okay, or in this case, see here, this equation. So this one applies when your boundary is composed of several segments of straight lines. So when you can decompose that into a set of trapezoids. So that is, for this one, you use this, is W is the width of each segment, 30, times H1 is this number, 34, and then H6 is this number, 23. These divided by 2 plus all the inside ones, plus 21, 23, 29, 31. Okay, do the calculation. And then for this one, the answer is 3,900 something. So it's most close to C. All right. And then the next one. The GPS latitudes and longitudes were taken on of a plot of land in the region where the plot is located, the length of a degree. So you may be given an area, a plot of land. It can be measured in the degree or in another projection system, so by feet. Either way, in this case is by degree. So how you do the calculation? You want to use this equation. So you calculate the area by coordinate. The area is, what does that mean? So you see point A, B, C, D here, right? So you use the x coordinate
of A. So in this case, it's X on the horizontal. So this is 122.8162. Okay, X refers to the horizontal axis. So 122.81 here. And then YB. So you move to point B, find the vertical coordinate. So north, south direction. So you use 47.3116 minus YN. So what is N? N is, go back here. N is when you go through here, the last point before you go back to A. Okay, so in this case is D. So minus 47.3104. Keep going. Plus XB, move on to here. You use 122.8163 times next point, YC, 47.3118 minus YA. So the other side of B. So minus 47.3105. So do the calculation until you have done this for each point. You have done this for point A, point B, point C, and point D. Okay. So finally, you're going to get the area because we're doing it using the degree as a unit. You're going to get, this is negative. We're going to get the negative value. Negative 2.62 times 10 to the power of negative 6. Okay. The last step is you need to remember to convert it back to feet and then convert to acre. Okay, because we're doing the degree ones. So you see this has already given, in this case, each degree in this direction is this many feet. Each degree here is this many feet. So using the degree you just calculated, multiply by 248160, and then multiply by 364320, you're going to get the square feet. Okay, but this one asks for acre, and then the conversion factor between square feet and acre is 43560. The solution probably is more straightforward. So you do the calculation and then do the unit conversion. Final is 5.44. So the answer is D in this case. Okay. Now next one. Next one. This one is this curve, and then using interval of 1, what is the most nearly the area under the curve predicted by Simpson's 1/3 rule? Again, this one asks for area. The difference between this one and this one is, this one again is the boundary line should be a set of straight lines. When it doesn't, it's not straight lines. When it's irregular or parabolic curve like this, you need to choose to use Simpson's 1/3 rule. Okay, this one. Okay. Another condition to use the Simpson's 1/3 rule is n must be odd number of measurements. So that is, you see, there is 1, 2, 3, 4, 5, 6, 7. Okay, 7 segment lines. So the segment lines needs to be an odd number, in this case 7. Or the number of segments needs to be an even number, in this case 6. So when this applies, you can use the Simpson's 1/3 rule here. So W again is length of interval. It's 1 in this case. Okay, it's the unit interval. And then H1 is a 2. And then 2 times everything from, you see, 2 times everything from here, 2 times 4 plus 1. So here and here, this is the third segment line, although it's marked as true, it's the third segment line. So 4 plus the fifth segment line to 1. And then plus 4 times the second segment line 4. The fourth one is 2. The sixth one is a 2. Okay? And then plus HN, the last one is also 1. And do the calculation. So the final answer is 15. Yeah. Okay? And then the last question on this page, polygon. And then using interval 1, what is the most nearly the area of a polygon predicted by trapezoidal rule? You don't need to memorize the whatever rule in this case. It's not given anyways. Just do simple geometry. Okay. This one cut off these several pieces. So this one, the answer is about 16.67. So the answer is C. Last one. Which statements concerning methods used to determine areas under a curve or line is or true? Trapezoidal rule applies to area where the irregular sides are curved. This is not true. Okay, when it's straight line, you can use the trapezoidal rule. Simpson's 1/3 rule only applies to an odd number of segments. And then the area by coordinate method can be used if the coordinate of the traverse leg and points are known. So, we know this one is wrong, and then this one applies to areas whose irregular sides are curved. First, this is the first condition. And then only to an even number of segments. So, as I said, there must be an odd number of segment lines. Refer to this one. Odd number of segment lines, but even number of segments. So this one is also false. Okay. The third one, the area by coordinates method can be used if the coordinate of the traverse leg endpoints are known, just like this one. So once these endpoints of each leg is given, we can use that area by coordinates equation. So this one is true. So only the third one is correct. Answer is B. Okay. And then another key section is geometric design. Geometric design on your reference book is covered quite extensively, I think. It could be the horizontal curve. Horizontal curve is on page 181. It could be the vertical curve, which is covered on page 182. Okay, vertical one here, all the equations for horizontal ones are here. Okay. Let's see. The first question. This is horizontal curve, so go to page 181. Let's use all these equations here. So the radius of the curve, the I, the intersection angle is given, and then the station of PC is given. The LC, the length of long chord is given. So find R. Okay, so this is very straightforward. LC is given, I is given, so just find R. Use this equation. Plug in the numbers, you're going to get about 520. So answer is A. Now, next one. Freeway route has a horizontal curve. Okay, horizontal again. PI station is given, I is given, and then radius is given. So ask for PC. The relationship between PI and PC is PI equals the station number of PC plus T. Remember that? And then PC therefore is station of PI minus T. This relationship does not hold true between PI and PT station number. Remember that? So all the station number needs to be traced back to PC. So in this case, the PC is located as PI minus T. Now PI's station is already known. The question is to get T. So let's check this. The news is radius is given, I is given, so we can directly use this equation to get T. And then we do the calculation, T is 191. So station of PC is therefore just PI minus this T. And then do the calculation is 910. So 910 feet, station 9 plus 10. Okay? Next one is the vertical stack curve. Vertical stack curve has a length of 8 stations and connects the first grade is -2, and then the departure grade is 1.6. PVI location also given, and then elevation given. It asks for the elevation of lowest point. I know in class we have learned a lot of equations. There are simple ones you can use, but if you don't remember all of them, you can always use the most general case, this one, curve elevation. Okay, this is on page 132. Curve elevation, you need to know the elevation of PVC. We know the elevation of PVC? Not yet. Okay? This is something we need to figure out. We need to know G1. We know G1. We do. Right? G1 is -2%. And then do we know this part? G2 minus G1 over 2L. L is given. Right? And then G1, G2 are given. So the all we need to know, number one, is Y elevation of PVC, and then also X of the lowest point. So Y of PVC, elevation of PVC, how can we get that? We can use, next one is the tangent elevation. So we know between PVC and PVI, the change of elevation is half of L, 4 stations for 400 feet, times the degree, 2%. So it's, the calculation is what? 8. Right, 8 feet elevation difference. So you use this plus 8. So PVC's elevation is given. So 2446. Okay. Now the question is, what is the X? The lowest point. Let's check again. Here. Oh, here. This is the horizontal distance to minimum or maximum elevation on curve. Okay, so XM, lowest highest point. And then the equation of XM is given here. Again, we know G1, G2, L. We can do the calculation. Plug in the numbers. Here. So G1 here, G2 here, and then L here, and then do the XM, and then plug in the XM as X and everything else given here. So you have the final answer here. Another thing I need to remind you is the consistency of the unit system. So if you use 100 here, feet here, you need to, for the grade, you need to use 0.02. Okay. If you use the station here, just 8, you can use 2. My personal preference is to convert everything to feet, because all the other parts, they use feet. It will get you confused. So convert everything to feet, and then keep using the 0.02. Next one. A 6% curve has forward and backward tangents that intersect at the station, PI station is given. So the station of the point of PC. So what's the station of PC? Okay. Again, we know the station of PI, we want the station of PC. All we need to know is this tangent. And then we also already know the intersection, or the intersection degree here. Okay? If we know R, only if we know R, once we have R and we have I, we can know the T. The question is, what is R? It doesn't give us R, but it gives us, it says it's a 6-degree curve. What is that 6 degree? The 6-degree curve. This is the degree of curve, D. Okay. You can just use this one directly. Okay. So, plug in 6 here, you get R. Do the calculation for R, around 950 something, and then plug in here, you get T is around 94, and then station here minus the 94 feet, so you're going to get answer is D. This one, another horizontal curve. So this one, you have LC, the long chord, and then the radius is given. Station of PC is given. You need to know station of PT. So station of PT is station of PC plus L, the curve length, L. Curve length, how can you calculate this one, is here. L is the curve length. Okay. Make sure you know the difference between LC and L. LC is this straight line's length of long chord. L is along the curve, this one. So L, you use this, you have R, you have I, plug it in, get L, and then station of PC plus L, you get PT. Okay? This is for geometric design. I personally also feel this practice problem missed something else that could be tested. That is the side distance. Let me see. Let me see if it covers somewhere else. It's not in this set. I don't think so. So, others that could be important for curves are here. So refer to page 175. In class, we only learned these two. The stopping side distance for crest curve and then stack curve. And then we learned that in most cases, you just need to use this set. So usually the curve length is longer than the side distance. So use this set. And then two other things that are listed. Sag vertical curve based on riding comfort. I haven't seen this one tested, but you know what this is for. And then another one is sag vertical curve based on adequate side distance and an overhead structure to see an object beyond the sag curve. So this one we didn't cover in class, but could be tested in the FE test. This is when there is a overpass or a bridge in front of you and there is a sag curve. How to make sure that the bridge does not block your view. So you want to use this one. The only thing maybe you need to review is you need to refresh your memory on what is H1, what is H2, and then how to calculate these S. Okay, just refresh your memory on these. And then the horizontal curve, same thing. You still remember this one? This is the consideration for super elevation. Okay. And then this one, again, I haven't seen it used, haven't seen it tested. It only applies for the horizontal curves where there is spiral transitional length. Okay, in class and then in most states, we only focus on the circular curve part. So this one is not that important. Side distance, this one might be more important. This is to make sure nothing blocks the curve, so you cannot see the other side when you turn it. This one. Okay. Unfortunately, I don't see the test questions here, so just review these equations by yourself. Earthwork. Earthwork, theoretically, is not part of transportation. It's part of construction. Has the instructor covered this, earthwork? Okay. So earthwork is just related to during the construction of roadway, when we have cut and fill, how do we calculate the volume? So this one is just a matter of calculating the volume. The equations are here, also on page 182. So you see this one is average end area formula and Prismoidal formula. So just basically different ways to calculate volume here. So for example, this one, earthwork quantities for a section of roadway indicate transition from fill to cut. The following areas are scaled from print cross sections where there are transitions between cut and fill. The cut and fill roadway cross sections are both triangular in shape. So each, so first station number here, and this is the cross section. You can tell from the unit, this is the area of the cross section. It's not a volume yet. So your job is to calculate the volume. So for this one, that is from this station to this station, from this station to this station, the cross section area changes from this to this. Okay. So how do you calculate the volume? Take the average of these two, multiply by the length. In this case is 10.5 feet between these two stations. Okay, so do the volume calculation. And then the next part, same thing. So you first do these two. The length is 11 feet, and then you first do the calculation for the fill again. Take the average of these two areas, multiply by 11. That's the fill volume. And then you also need to do the cut part. The cut part, this is none. What does that mean? That means the cut part transitioned from 0 to 154. So we're no longer calculating the volume of prism. We need to calculate the volume of the pyramid. Okay, so the area of the base divided times height divided by 3. So 154, this area, times the height, 11 divided by 3. Okay, so this is the cut part. And then for the others, the remaining part of the calculation follows the same process, the volume of prism. Okay, let's see. Finally, you do all the calculations. I'll just show you the solution. So you do all the calculations listed here. You do the cut volume, the fill volume between each station. Okay, and then you take the sum. This question asks for the total volume of fill required. So just the summation of all these numbers. This one gives you the depth at each point, and then asks you for this 2.6 is the depth in feet. Again, it asks for the calculation of volume. First, you need to, I'll just explain the solution here. Okay. Now, first summarize all these different grids as the cell number. And then the first column, you want to calculate the area. Okay. The 2 is half of the square. It's a bit different. And then another thing is to calculate the average depth of undercut. Now the question is, how do you calculate the average? For example, cell 1, you have 4 different numbers on the end. So you basically do the median, or the average of these 4. Okay? So average of the 4 columns. And then for this case, you get 2.95, and you use 2.95 times this one to get a volume. So it's sort of taking the average, it's sort of like getting average depth in this cell. So the total volume, you will calculate it here, and the last step is converted from cubic feet to cubic yard. Okay. Question 3. The table represents the area of cut and fill of 3 consecutive roadway points along a rural road project. The amount of borrow or waste between this is very similar to the first question. You need to do the calculation of volume, cut volume and fill volume. Okay. In this case, you repeat the process. You are going to get, okay, repeat all the process, doing all the calculations, and then you get the total cut volume, you get the total fill volume. But this one is the net, or the volume, borrow volume of waste is just the net, the difference between these two. That's it. So, the answer is D. Now this one, earthwork. The total volume of fill required. It's the same thing. Okay, just to calculate the volume. Whenever there are 2 numbers available, you want to use, in reference book, you want to use this one, average and error formula. Whenever you see one number missing, you need to use this one, pyramid or cone formula. So that's for earthwork. Okay, pavement. Pavement. On your reference book, pavement-related information is page 180 and then page 179. Okay. So the first one, super pave. So everything here. Okay. Super pave design gives you all the numbers for air voids, everything. So this is designed for a 19 millimeter super pave. So let's see. So for this one, you just need to check all these tables. Let me see. So air voids, 4%. So for example here, 4% air voids, and then 19 millimeter super paved mixture. The VMA is 13. Okay, and then you check the VFA. Similarly here, VFA is you check traffic. Traffic is less than 10 million. Okay, so less than 10 million. So it's between 65 to 75. Okay, so this is also in the range. Okay, the dust to binder ratio. Dust to binder ratio. Let's see. Dust to binder ratio. Where is it? Dust to binder ratio. Is should be between 0.6 to 1.2. I cannot see this here in this table. Anyway, so for this type of question, all you need to do is just to check these numbers, four numbers here, and then to see if these numbers are within the range. This one, the answer is A. All the parameters are within an acceptable range. Again, I haven't seen a question like this in the FE test. It's just been an overkill, and then it doesn't really test much. This one, what is the approximate load equivalency factor for a 32,000 pound tandem axle truck? Okay, so for this, let me see, there should also be equations to calculate LEF. Calculate load equal. So it's on page 179. Oh, yes. Yeah. So the table is here. This part is how to calculate the load. So what is the approximate load equivalency factor for a 32,000 pound tandem axle truck? So tandem axle truck, and then 32,000 pounds here. Oh. Check the table here, and then the tandem axle here, 0.857. Okay, and then so this multiplied by that's it. The answer is 0.857, so answer is B. The next one, a road leading to a stone quarry is traveled by 40 trucks, with each truck making an average of 10 trips per day. When fully loaded, each truck consists of front single axle transmitting a force of 10,000 pounds, and two rear tandem axles, each tandem axle transmitting 20,000 pounds. The load equivalency factor, okay, so in this case, the load equivalency factor are given, these two. And then it asks for this many equivalent single axle load for the truck traffic on this road for 5 years. So in this case, we first need to calculate, let's show you on paper. We first need to calculate this equivalent single axle load. This, for the entire truck, you need to add up all the front axles and the rear axles. So there is one single axle at front, so 1 times this load equivalent factor, and then 2 times its own load equivalent factor. So this is for each truck. For each truck, the load is equivalent to this many of single axle load for each truck. And then the question says there are 40 trucks, each making 10 trips, and then it's asking for calculating for 5 years. So multiply by 10 trips per day, multiply 40 trucks, and multiply 365 days per year, and then 5 years. This is the total. Okay, this is the use of the table, basically. The most commonly seen questions, though, is question 5. I've seen this one most frequently in different types of practice problems. So this one is the highway pavement design has the material specification shown. So the pavement has several layers, subbase, base, and surface. Each one gives you the material and the layer coefficient and layer thickness, asking for the structure number. For this, all you need to do is to use this equation here. This is the structural number you're going to calculate. A is the layer coefficient, and then D is the thickness. So therefore, for this one, it's just 0.11 times 12 plus 0.14 times 15 plus 0.44 times 6. Add them together. Calculation is very easy. So the answer in this case is C. That's it. Okay. Next one. Let's see if we covered everything in the reference book now. Yeah, we covered almost everything in this reference book except for something on page 178, traffic safety equations. Traffic safety equations. There are still some formulas that we haven't got a chance to use. So for this one, you don't need to really memorize anything. It's just like application or work problem. Calculate crash rates at intersection is number of crashes divided by volume, or crash rates per roadway segment is number of crashes divided by vehicle miles traveled. Okay. Most frequently tested is this one, crash reduction. It looks really confusing. I think there is a much easier way to do the calculation. Okay, let's take a look at this one. What is the design perception reaction time in AASHTO for calculating stop to sight distance? 2.5. Okay, so this one is easy. Let's see. What is the accepted normal limit of peripheral vision? I have no idea. Just give your best guess. 160 maybe. Yeah. Yeah, this way. Right. 160. So no way is 180. And 80 is 2. So some of these problems, just use your common sense. What is the maximum light intensity contrast ratio perceptible to a human eye? Just memorize this number. I cannot memorize it. 3.1. What percentage of roadway fatalities occur in a work zone annually? 2%. I cannot remember this either. You may want to memorize this number in case we test it. But I want to show you something else so another handout I printed out is this set. So the transportation part start from question 77. right? So the first one is easy. Curve elevation, the vertical curve. Remember the vertical curve elevation is y of PVC plus AX1 plus the BX squared. Remember? So we've already covered this one. Similar questions, I'm not going to go through this one. Okay, this one. This highway profile, okay, this is a practice on design stopping side distance. And then driver's eye height is this, and the height of object is this. Minimum design length. So this is obviously a question, give you S, give you H1, give you H2, and ask for L, right? Okay, so that's great. We finally find the use of a formula here. The previous table of stopping side distance I mentioned. Is we want to use this one. We want to use this one. Okay, this is a crest curve. Crest curve, stopping side distance. Given stopping side distance, and then here. So the question is, what is A? A is the difference between the two grades, starting and ending grades, right? So 4 plus 4, negative 5, so 9%. So we use 9 times 600 feet divided by the H1, H2 are not standard in this case, so you cannot use this one. Is it? Is it standard? No. This number only applies when H1 3.5, H2 is 2. In our case, H1 is 3.5, but H2 is 1. So plug into this one. Plug it into this equation. Do a calculation of that. Okay. This is the horizontal circular curve. Station of PT. We know station of PT is just the station of, we cannot use station PI plus T. We first need to get station of PC, right? So use this minus T to get station of PC. And then use the station of PC plus L to get station of PT, right? So, okay. Something, this one. At two-way stop control intersection, the side distance required for minor street movements is determined by. So this one, the answer is B. This is something we didn't cover in class and it's not included in the reference book either. So we talked mostly about stopping side distance or other things that could block distance, side distance. Now this one happens when you stop at this minor road and then to move after stop sign is you need to have a clear view of this direction and this direction. You need to have a clear view of this direction and this direction. So there cannot be blocked here, or there cannot be blocked here, right? Otherwise, it cannot be that part. So this is called it's called departure side triangles. Okay, so departure side triangles. AT1, you know how to do this now. The structural number, right? Structural number thingy. It's just weighted sum. Okay. 82. This is something you also want to memorize. For a given loading, soil condition, and design life, which of the following pavement types will most likely to be the thinnest highway pavement design? You need to remember asphalt, as long as it involves asphalt, it's typically thicker. Okay. So the rigid concrete will be the thinnest. So the answer is C. Okay, Portland cement, concrete will be thinner. All the others have some asphalt. Okay, here is the crash rate reduction or crash reduction. This one. You can use the equation on the reference book, but I personally prefer my way. This one, it says the number of crashes per year is 10. And then two mutually exclusive countermeasurements have crash reduction 0.25, 0.15. These two numbers are not additive. They are sort of multiplicative. So after the first one, it's reduced by 25%. So it reduced to 7.5. After the second one, it's reduced by another 15%. So 7.5 times 0.85. And then you do a calculation, the answer is D. This is my way. I think it's also easier to understand. Okay, so 10 times 75% times 85%. Okay, this one. 84, question 84. Person is driving on a carved road and have a gravel surface. A deer suddenly leaps into the road. The road is on a 10% downgrade, and then the car is traveling 50 miles. And the driver reduction is 1.5. Coefficient of friction is 0.65. And then the coefficient of friction is given like this. The total distance required to stop. So this is the stopping distance, braking distance. So the reference book is also, you can find it here. On page 175, this is the stopping site distance. The equation is here. Okay, plug in all the numbers. Remember this V, when you plug it in, it should be, let me see, the V here, just pay attention to the unit. The unit here it gives is 50 miles per hour. 50 miles per hour. So V, you want to use miles per hour. Okay? Because the other coefficient has already helped you convert this. Okay? So this too, you can insert it into 50. Okay? And then do the calculation in this one because it's downgrade. So you can just say downgrade, it takes longer to brake. So it's minus this G. Okay, so minus 0.10. And this part gives you is 0.65. So overall, the calculation is about 261 something. So answer is D. 85. Okay. This is another thing that might be tested. The basic concept of spacing. So this one, volume is 1,400, and then the time spacing. Time spacing is just the reverse or the reciprocal of the volume. Just pay attention to the unit though. It asks for a second, but this volume is given per hour. So it's 3,600 seconds divided by 1,400. That is, answer is 2.57, or you can interpret it as about every 2.6 seconds there will be one vehicle. That's the interpretation of time spacing. This one. 86. This one. This one is, I think this one is also covered somewhere. The walk distance. Okay. '86 is the time used to walk. So the initial walk signal is displayed for 6 seconds, after which a flashing don't walk signal is displayed, and the walking speed is 4, street width is 50, after the green, the yellow interval is 3.5, all red is 0.5, So the length of time the green must be displayed. So that means the pedestrian must be able to go across the street within the effective green time. So this one is so the walk time plus the time it takes for the person to go through this intersection. So with 50 divided by 4 is 12.5. This is the time needed for this person. And then the walk time plus this time minus yellow time is the green time. I don't think this one will be tested either. The others, let me see. Are there any more translation questions? No, I think that's it. Well, there are a bit of earthwork type of questions here in the last several ones. So 96 is another earthwork one. Not really. This is more of a construction one. It's 98. Calculate the volume. Earthwork one. And then let me see what else. Oh, and then 99. 99 is that a closed traverse. So the area of closure. This is also an overkill. It's not even in the reference book. Never mind. This one, area inside the quadrilateral, blah, 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 between the, this is more of a geometric problem. So shaded area is the total area minus this, this sector here. So total area is the T times R, right? And then divided by this sector. This is pi r squared divided times this I, or 360. It's a geometry problem. So I think that's it. Am I going too fast? Huh? Oh, okay. My assumption is, I was told, because you guys have already learned them, so I only need to go through the practice problem. I guess the best way, I personally think the best way is to go through the reference book. Just know how to use them. And then the next thing is to go through the solutions, one round. That's it. Transportation problems, if you simply cannot memorize something, just use your common sense to give your best guess. Usually it's correct. That's the best thing about transportation. It's different from structural. You have a better sense of what's happening in transportation. Okay? Yeah. Okay.